Lesson: Best Practices for Explainability. Explainability in artificial intelligence systems is crucial for fostering trust, ensuring compliance, and promoting ethical use. Best practices for explainability revolve around transparency, interpretability, accountability, and user-centricity. These practices are essential for professionals in the field of AI compliance and ethics to evaluate and improve AI systems effectively. Implementing these best practices requires actionable insights, practical tools, and frameworks which can be directly applied to real-world scenarios. Transparency is the cornerstone of explainability. It involves making the decision-making processes of AI systems visible and understandable to stakeholders. One effective way to achieve transparency is through the use of model-agnostic tools like LIME and SHAP. These tools provide insights into the predictions of complex models by approximating them with simpler, interpretable models. LIME, for example, perturbs the input data and observes the changes in predictions to create a locally faithful explanation model. SHAP, on the other hand, assigns each feature an importance value based on cooperative game theory, offering a unified measure of feature importance. By applying these tools, professionals can identify which features most significantly influence a model's predictions, thus enhancing transparency. Interpretability is closely linked to transparency and refers to the extent to which a human can understand the cause of a decision. A practical framework for achieving interpretability is the use of inherently interpretable models, such as decision trees, linear regression, and logistic regression. These models, by their nature, provide straightforward insights into how inputs are transformed into outputs. For more complex models, techniques such as feature visualization and activation maximization help in understanding what specific neurons or layers in neural networks are learning. For instance, in convolutional neural networks, feature visualization can reveal which patterns in images are being identified for classification tasks, thus improving interpretability. Accountability in explainability entails assigning responsibility for the decisions made by AI systems. This can be achieved by establishing clear documentation and audit trails for AI models. A practical tool for this purpose is the Model Cards framework, which provides structured information about a model's performance, intended use cases, and limitations. By maintaining comprehensive documentation, organizations can ensure accountability and facilitate audits by compliance officers and ethics boards. This documentation also assists in identifying potential biases or errors in the model, allowing for timely interventions. User-centricity emphasizes the importance of tailoring explanations to the needs and understanding of different stakeholders. The XAI framework suggests designing explanations that are context-aware and audience-specific. For example, explanations for data scientists might focus on technical aspects of model performance, while explanations for end users might emphasize the impact of certain features on predictions. By using personas and user studies, professionals can design and test explanations to ensure they are meaningful and actionable for their intended audience. A notable case study illustrating these best practices is the application of AI in healthcare, where explainability is critical for both clinicians and patients. A study conducted on AI models used for diagnosing diabetic retinopathy demonstrated the effective use of SHAP to reveal which retinal features were most influential in the diagnosis. This not only improved the model's transparency, but also increased clinicians' trust in the AI system, as they could verify the model's reasoning against their own expertise. Furthermore, by providing patients with simplified explanations regarding their diagnosis, the healthcare providers enhanced patient engagement and satisfaction. Addressing real-world challenges in explainability requires a combination of these best practices. One common challenge is the trade-off between model accuracy and interpretability. Complex models like deep neural networks often provide higher accuracy but lower interpretability compared to simpler models. To tackle this challenge, professionals can use a hybrid approach by employing interpretable models for initial predictions and complex models for subsequent refinement. This approach ensures that stakeholders have a baseline understanding of the decision-making process while benefiting from the accuracy of advanced models. Another challenge is mitigating bias in AI systems, which can be exacerbated by opaque decision-making processes. Explainability tools and frameworks can play a vital role in identifying and addressing bias. For instance, by using SHAP values, professionals can detect disparate impacts of features across different demographic groups, enabling targeted interventions to reduce bias. Moreover, incorporating fairness constraints into model training and validation processes can ensure that AI systems are not only explainable, but also equitable. Statistics underscore the importance of explainability in AI systems. A survey conducted by Deloitte revealed that 57% of respondents consider explainability a critical factor in trusting AI systems. Furthermore, a report by the European Commission emphasizes that explainability is essential for ensuring compliance with regulations like the General Data Protection Regulation, which mandates that individuals have the right to obtain meaningful information about the logic involved in automated decision-making. In conclusion, best practices for explainability in AI systems are vital for fostering trust, ensuring compliance, and promoting ethical use. By focusing on transparency, interpretability, accountability, and user-centricity, professionals can enhance the explainability of AI systems in practical, actionable ways. Tools like Lime, SHAP, and frameworks such as Model Cards and XAI provide valuable resources for achieving these objectives. Real-world examples, such as the application of AI in healthcare, demonstrate the effectiveness of these practices in addressing challenges and improving decision-making. By integrating these best practices into their workflows, professionals can significantly contribute to the development of trustworthy and ethical AI systems.